All right, so you sent in a whole bunch of articles about this year's Nobel Prize in Physics, and I gotta say, this deep dive is not our usual fare. Like, we're not diving into black holes or quantum mechanics this time.
No.
This year, it's all about something you probably use every single day, artificial intelligence.
And what's really wild is that the prize went to physicists for figuring out how to make machines learn. Like, that's mind-blowing.
Hold on, rewind that for me.
Yeah.
Physicists are the masterminds behind AI.
They are.
So, like, those spam filters that magically disappear annoying emails, or those music apps that seem to know my taste better than I do, that's all thanks to physics.
You got it. It all goes back to those early days of computers, when it was all about crunching numbers.
Yeah.
But then came the really tough question. How do you get a computer to actually recognize a pattern? Something that we humans do without even thinking about it.
Right, like telling the difference between a picture of my dog and my neighbor's cat. My phone can do it now, no problem. But I'm guessing those old school computers would have really struggled with that.
Absolutely. Back then, they tried programming computers with all these super specific rules, like a step-by-step manual for thinking. But you can imagine how crazy complicated that got, especially for something like image recognition.
Yeah, it's like trying to explain every single detail of riding a bike.
Exactly.
It's just easier to show someone.
Right.
So how did they get around that problem? Did someone have like a light bulb moment, a eureka moment?
It wasn't really a single eureka moment, more like this gradual realization that the answer might be in mimicking the human brain itself.
Interesting.
Researchers started looking at how our brains process information using these networks of neurons and synapses.
Oh, okay. So instead of rigid rules, they started thinking about connections and networks, kind of like mapping out the brain.
Exactly. And that's where our Nobel laureates come in.
Okay.
John Hopfield, a physicist, was fascinated by how this whole network idea applied to something totally different: magnets.
Wait, magnets? Like the ones holding up my kid's artwork on the fridge?
Yep, those magnets.
What do magnets have to do with AI?
It's all about the way atoms spin inside the magnet. Hopfield realized that the way these spins line up and interact could be a model for how information is stored and retrieved in a network, like a simplified version of how our brains store memories.
Okay, I need a little help here.
Sure.
Are we saying he built a tiny brain out of magnets?
Not a physical brain, no.
Hmm.
But he basically translated those magnetic spin interactions into computer code and created a network that could actually learn and recognize patterns.
Wow, so he gave a computer a memory upgrade by taking inspiration from magnets. That's pretty wild.
It is pretty cool.
But the articles you sent also mention another Nobel Prize winner, Geoffrey Hinton. How does he fit into all of this?
So Hinton took this idea of mimicking the brain to a whole new level.
Okay.
He was interested in how machines could learn from experience, just like a child learns to identify objects without someone explaining every little detail.
Okay, so instead of giving the computer a dictionary definition of a cat, Hinton's idea was to show the computer a bunch of cat pictures and let it figure it out on its own.
You got it. That's the basic idea.
Wow.
And to do this, he found inspiration from a pretty unexpected source: 19th century physics.
Well, 19th century physics, like when electricity was brand new?
Yep, that old.
What could that possibly have to do with teaching a machine to learn?
It's a fascinating connection, right? So Boltzmann, this physicist back then, was studying how gas molecules behave.
Okay.
He realized that even though you can't keep track of every single molecule, you can still understand and predict how they all behave together.
Okay.
Hinton saw a link here to artificial neural networks.
Okay, I'm hooked. How did he connect the dots between gas molecules and AI?
He created what we call the Boltzmann machine.
Okay.
Imagine a network with two types of nodes: visible ones where you input data like those cat pictures,
Right.
and hidden nodes that aren't directly fed any information.
Interesting.
And these hidden nodes, through their connections and interactions, they allow the network to find patterns in the data patterns that aren't immediately obvious.
So it's like those hidden nodes are working behind the scenes, like detectives piecing together clues from the visible nodes?
That's a great way to put it. Those hidden nodes are the key to the learning process.
Yeah.
They help the machine go beyond just memorizing data and actually start to understand the relationships.
This is already blowing my mind, and we're just getting started.
It's pretty amazing stuff.
It sounds like these Boltzmann machines were a pretty big deal. Did they solve all the AI puzzles right then and there?
They were huge, but they did have their limitations. They were what we call computationally expensive.
Expensive. Like my grocery bills these days? Or are we talking about something else entirely?
No, not like your grocery bills. It means they needed a massive amount of computing power and time to learn. Remember, computers back then were nowhere near as powerful as what we have today.
Ah, okay. So it's like trying to run a marathon on a treadmill that can barely handle a light jog.
Exactly. They needed an upgrade.
They needed a serious upgrade.
They did.
So they had this great idea, the Boltzmann machine,
Yeah.
but it was like trying to run a marathon on that old clunky treadmill.
Yeah.
How did they give it that speed boost it needed?
Well, they figured out that sometimes less is more.
Okay.
By simplifying the connections in the network, like actually getting rid of some links between those hidden nodes,
Right.
they can make it way more efficient.
Yeah.
And they called this the restricted Boltzmann machine, or RBM for short.
Okay, so a little less chit-chat between the hidden nodes, a little more action. Got it. But doesn't that mean less learning capacity too?
That's the thing. It actually didn't reduce it that much.
Yeah.
They found this sweet spot where they could really boost the speed, make it less computationally expensive without sacrificing too much learning power. It's like streamlining a recipe using fewer ingredients but still getting that amazing flavor.
Fewer ingredients, faster cooking. I can get behind that analogy. But let's face it, the real world is a lot messier than a simple recipe. How did they teach these RBMs to deal with, well, everything?
Now, that is a fantastic question.
Yeah.
And it brings us to one of the biggest breakthroughs in AI.
Okay, I'm ready.
Imagine taking those streamlined recipes, those RBMs, and stacking them on top of each other.
Like a layer cake of learning.
Exactly. Each layer gets information from the one before it processes it and then passes it on to the next layer. And this creates what we call a deep neural network.
So instead of just one layer of hidden nodes trying to figure everything out,
Right.
we have multiple layers, each specializing in different parts of the problem.
Yeah.
Is that what makes deep learning so powerful?
You got it. Each layer learns these progressively more abstract features. Think about how we recognize faces.
Okay.
The first layer of our visual cortex might just see edges and lines. Then the next layer uses that to see noses, eyes, and so on, until our brain puts it all together and says, hey, that's your friend. Deep neural networks, they work in a similar way.
So they basically created an AI that processes information more like our brains do.
That's the idea.
That's amazing. But I have to imagine training these multi-layered networks with all those connections must take forever, even with the RBMs.
You're absolutely right. Training those deep networks was a huge bottleneck. But Hinton and his team, they made another breakthrough.
Okay, tell me more.
They realized that if they pre-trained each layer of the network with an RBM, they could give it a massive head start in learning.
Hold on, pre-training. So it's like giving each layer of the cake a little taste test before putting the whole thing together.
That's a great way to put it. It's like giving each layer some basic skills before throwing them into a Michelin star kitchen. This pre-training sped things up dramatically, made it possible to build and train much larger, more complex networks.
Okay, so we've gone from these slow and expensive Boltzmann machines to these super efficient, multi-layered deep learning networks that kind of learn like we do.
Right.
That's a lot.
Yeah.
But this is where the rubber meets the road, right? Like, what's the big payoff? What can we actually do with all this AI power?
That's the most exciting part. The applications of deep learning are pretty much endless. It's what powers those personalized recommendations you see on Spotify or Netflix. It's helping doctors diagnose diseases like cancer much earlier. And it's being used to create self-driving cars, even new forms of art and music.
So it's not just about making our lives easier. It's about pushing the limits in medicine technology art. That's pretty incredible. But the articles you sent mentioned that AI is being used to solve some big mysteries in physics, too.
Oh, absolutely. It's a perfect example of how different areas of science can work together and lead to amazing discoveries.
Cool.
For example, physicists at the Large Hadron Collider are using deep learning to analyze tons of data, searching for new particles and forces.
So it's like giving physicists a superpower, letting them analyze data on a scale they never could before.
That's a great way to think about it. And it's not just about analyzing data. AI is also being used to actually design new materials with specific properties, leading to advancements in everything from renewable energy to quantum computing.
Wow.
That's pretty amazing.
So we've gone from mimicking the brain to revolutionizing physics research. This Nobel Prize story is definitely one for the books. But, the articles also mention some bigger questions, even some anxieties about AI. What happens when these machines become smarter than us? Should we be worried?
That's a question that deserves its own deep dive.
Right.
Because it's true, the rapid progress of AI raises some serious questions about the nature of intelligence consciousness, even the relationship between humans and machines.
Yeah.
And it's something more and more people are thinking about as AI becomes a bigger part of our lives.
So it's not just about the technical stuff anymore. It's about really understanding the impact of what we're creating.
Absolutely.
Yeah.
And that impact is huge. Everything from the future of jobs to what it even means to be human in this age of intelligent machines.
This has been an eye-opening conversation, to say the least. We've covered so much, from the link between physics and AI to the massive implications of this technology.
We have.
But I think the big question on everyone's mind is, what's next? Where do we go from here?
That is the million-dollar question, my friend. And it's one we'll tackle in the final part of our deep dive.
Okay, so we've gone from spinning magnets to, like, the mind-blowing possibilities of depth learning.
It's been quite a journey.
It really has. But I think you're right. The real cliffhanger is what happens now. Like, what does all this mean for us regular folks?
Well, the future of AI, it's not like some pre-programmed thing. It's more like we're all writing the story as we go.
Okay, so how do we make sure we get a happy ending? Those articles mention some pretty big changes on the horizon.
Oh, yeah, for sure. One of the biggest things is how AI could totally change the way we work. Like, imagine AI taking over all those boring, repetitive tasks.
Okay.
And that frees us up to focus on things that really make us human. Creativity, problem solving, stuff like that.
So instead of AI stealing our jobs, it's more like it becomes our super efficient sidekick.
Exactly. It's all about teamwork, not replacement. But it does mean we got to rethink how we educate people for the jobs of the future. We need to focus on skills that AI can't just replicate.
Makes sense. We need to be adaptable, always learning. But thinking bigger picture here, one article mentioned AI could be huge in tackling some of the world's biggest problems, like climate change.
Oh, absolutely. AI could help us design smarter cities, make our energy grids way more efficient, even develop new ways to capture carbon from the atmosphere. It's about using AI not just to understand the problems, but to actually help solve them.
That's a powerful idea.
Yeah.
Using this technology to make the world a better place, not just our lives easier.
Exactly.
But I gotta be honest, a part of me still feels a little uneasy about all of this.
I get it. It's natural to feel that way. We're talking about something that really challenges how we think about intelligence. But instead of fear, I think we need to be informed too. Ask tough questions and make sure we're building AI that aligns with our values.
So less Hollywood doomsday scenarios, more like having a real conversation about the kind of future we want with AI.
Exactly. And everyone needs to be part of that conversation, not just the tech geniuses. We need to talk about the ethics, the potential for bias in algorithms, and how to make sure AI benefits everyone.
So where do we even begin? It all seems so huge and complicated.
It starts with curiosity. Just start learning about it. Don't be afraid to ask those big what-if questions, because the future of AI isn't set in stone. It's something we're all creating right now through the choices we make.
You know, hearing all of this, it really hits me that this Nobel Prize wasn't just about a scientific discovery. It was like a challenge to keep exploring, keep asking questions, keep pushing the boundaries.
I like that. That's a good way to put it.
And who knows, maybe someday there'll be another Nobel Prize for work that builds on all of this work that was inspired by conversations like the one we're having right now.
That would be incredible, to see this work spark even more groundbreaking research and ideas.
That's the beauty of science, right? It's always evolving, always pushing us to think differently.
Absolutely.
Well, to our listener out there, thanks for joining us on this incredible deep dive into the world of AI and physics. We hope you learned something new today and maybe even feel inspired to learn more.
And remember, the future is unwritten.
The most important question isn't what if.
It's what's next.
Until next time, keep those questions coming.